What's more iconic than a game of Holochess? From a galaxy far, far away to my workshop, join me as I build my DIY Holochess table. It can make game pieces appear on the board almost like real holograms. And it represents a simple but playable variation of Holochess. In this video I will show you how it works and the process of creating it. Stay tuned. In a previous video, I introduced the idea of aerial displays, and I have to admit the concept has been on my mind for a while. While doing more research on the topic, I was surprised to find companies that make professional parts for these aerial displays. One such company is SCAS3D, a Japanese organization which manufactures components only for aerial displays. I found that remarkable. I always thought this was an exotic niche application, but it looks like there's a real market for it. Anyway, their main product is a special optical plate, which is supposed to do the job of the beam splitter and the retroreflector all in one, making the whole setup much easier. If you are not familiar with the principle of aerial displays, please refer to my last video, in which I showed a simple construction of a floating display based on a beam splitter and a retroreflector. As a little refresher, here's the principle in a nutshell. Outgoing rays from a bright display are first partially reflected by the beam splitter, then reflected back in the same direction by a retroreflector, and finally converge above the unit, creating the illusion of a display floating in the air. Now the same result should be possible with this product, but without the key components mentioned. Of course, this made me curious, and I decided to take a closer look at the product and ordered one. By the way, this video is not sponsored or anything, just to be clear. After I unpacked the box, I found a 20 by 20 cm piece of plexiglass. At first glance you can't see much, just a kind of optical distortion effect and a very fine grid structure. But when I hold it over a display, I'm really surprised. You get the same effect as with my last floating display setup. From the front, it looks like there's an image floating in the air. This is quite impressive. The construction is way easier and the image quality is much better. It is sharp and bright. So how does this work? The manufacturer's website says it uses a combination of overlapping reflective strips placed very close together. Of course, I was interested in finding out more, so I took a closer look under the microscope. And sure enough, I can see an arrangement of very fine reflective strips. As far as I understood, the principle is like an extension of a corner reflector. In a corner reflector, the light is always reflected in the direction it came from because of perpendicular reflective surfaces. Now imagine they are replaced by long reflective strips, and we use only two of them placed on top of each other. And voila, you get exactly this arrangement. The resulting beam path is similar to my previous setup, but much more compact. The rays hitting the plate from below are deflected upwards at an angle by the two reflective surfaces. The initially diverging rays converge at a point in the air outside, above the panel, creating the illusion of a floating image in the air. A pretty clever component. So what could I build with it? At first, I wasn't sure if I really should make another aerial display like the last one, but then I did a couple of experiments with the plate and noticed something interesting. Because of the brighter image, it somehow works through semi-transparent materials. For example, when I held a piece of smoked plexiglass in the path of the beam, I found that you can get a perfect representation of a transparent object that appears exactly on the plexiglass. So we can magically make a hollow object appear on a surface. And And this immediately reminded me of something. Exactly, Holochess. You know, the game you shouldn't play too hard on weakness.
You can't wipe them off, they're holograms.
Also in Holochess, the monsters appear as holograms on the chessboard. The idea was just too tempting, so I decided to build my version of a Holochess table based on this optical component, because why not? Alright, we've got our optical plate, and we can put a round chessboard made of some transparent material on top. For the monsters, we need to have some displays below. If we want to move the monsters, the displays would also have to move. But I can't move all the displays to any position. This is the reason why I could not implement a full Degenerate game. Instead, I decided to make a stripped-down version where only 2 monsters fight in the middle and the other set pieces are placed at the edges, in a waiting position, if you will. As you can see, this is maybe a pocket version of Degenerate or something like this. Perhaps a variation for lone pilots on long flights where no crew members are available to play, who knows. So, we need a few smaller displays, each showing a hologram. Luckily, we can find some low-cost displays that work well for our needs. I decided to use this very popular and inexpensive display module. It has quarter VGA resolution and you can buy it for less than 10 euros. The display module is controlled by SPI and has an onboard display controller, which contains a frame buffer. So only image updates need to be transferred, which reduces the load of the main CPU. As always, I made my first tests with the Arduino Giga, but it simply has too many limitations. Since I wanted to try out this successor for a long time, I decided to use the Arduino Giga for this project. The Giga not only has a much faster processor based on ARM M7, it also has more memory on board. Especially the 8 MB external SDRAM is great for storing graphics data. And the Giga has another advantage: you can read data directly from a USB drive. It also has many available I/O pins, some extra serial ports, and an onboard DAC for sound output. So even it's not exactly cheap, the Giga was a great fit for my project. First, I tested operating 2 display modules in parallel. It is possible to use more than one display because each display has its own chip select pin. I decided I need 6 displays in total, 3 on each side. I made this choice just because of the available size. For 6 displays, I need something better than this mess of loose wiring. So I made a stripe board PCB, which acts as a breakout connector for the displays. Alright, we have successfully connected all display modules and are able to control them separately. Now we need a more stable construction for our displays. I created a structure in Fusion to provide a solid base for the individual displays. I'm going to use aluminum profiles for the frame again because they have worked well in the past for me. As explained before, there are 2 displays on each side for the static game pieces and a central display for the fighting monsters. My idea was to make the central displays move to animate a fight between 2 monsters. So I put them on gantries to make them movable. The PCBs are placed right under the display unit to keep the cables as short as possible. Once my design was finished, it was time for printing and assembling all the parts. To ensure stability, I mounted the entire structure on a round base plate. Then I attached two vertical profiles to the sides to support the upper elements, which are a frame for the optical plate, which can be tilted slightly to allow better light efficiency, and a support bracket at the upper end. This part should later hold the ring-shaped table part, which is the most important and distinctive design element of a Holochess table. Also, it will secure the round transparent chess field right at the top. For this, I sketched the Holochess playing field in a 2D drawing program and simply printed it out on a transparent foil with my inkjet printer, and then cut it into a round shape. The foil is then placed onto the top part and is held securely by a ring element with inserted magnets. To insert the magnets into such elements, you can use any slicer to create a print pause at any point and then insert the magnets before the printer continues, so that the magnets are completely embedded. For the Holochess monsters, I found this fantastic work by Project 842 on Etsy and bought it. Thanks for the incredible work, link is in the description. The models are actually intended for 3D printing, but they can also be positioned freely in Blender. So we could set the camera and light positions for all the pieces accordingly and save the resulting bitmaps. My son helped me with this step because he knows Blender much better than I do. He wrote a script to automatically save the figures in all camera positions. This made my work a lot easier. Thanks for your help, Manuel. Now the Giga can read the images from a USB flash drive and show them on the display depending on the required position. Small animations are also possible, but this is really time consuming to set up all the necessary steps in Blender, so we did it only for a few animations. You get a lot of respect for the original Star Wars stop motion team when you try to create something like this yourself. It was time to design the iconic table part. The original Holochess table is a round metal structure controlled from two sides. Since my version is designed for a single player only, I decided to omit the second control panel. My design was created from scratch. First, I sketched the profile in Fusion, then used the sweep function for rotation. Here you see me designing the control panel, which was quite time consuming. The complete design has a total of 8 parts, 6 for the frame and 2 for the front panel. Time to print all the parts. It took 4 hours to print a single piece. So in total it took over 30 hours to print all the parts for the table. But to make it look like the original Holochess design, there is still plenty of work to do. The first step is to remove all the supports and assemble the parts. I use bolts to join the ring pieces together to get the most accurate fit and secure connection. Before sanding, a filler is applied to small gaps and seams in certain areas. I use plastic putty, It's easy to work with and ready to use. And now we get to the most important part, sanding. This is where I usually spend the most time, and this part is crucial to how smooth the result will be. I start with 120 grit sandpaper and work my way up. Before proceeding to the next step, safety first. Always wear gloves and a respirator when doing this type of work. When spraying the parts with filler primer, it is important that we apply the primer in thin, even layers. The primer filler covers any unevenness and allows the paint to adhere well. Quick, short strokes are best, starting in front of the object and finishing behind it. This is what the ring looks like after the first coat of primer. The surface now looks much more even, but you can still see the layer lines and some imperfections. Now we come to my favorite part, wet sanding. I repeatedly dip a piece of 400 grit sandpaper in water and use the same technique of sanding in circular motions throughout the process. You can also do that by listening to the sound. At first it sounds like a bit scratching over a record, but after a few minutes this typical sound disappears. Then you should stop. The area will be nice and smooth. And this is what it looks like after the second coat of filler primer. The surface is much better now. However, some areas are still not perfect. So let's do another pass. I wet sand again, this time with 600 grit sandpaper. After drying and applying the third coat of filler primer, the surface is now smooth, continuous, and there are no more layer lines visible. Now it's time for the base coating. A base coat should not be confused with the primer. The primer mainly creates an even surface. The base coat, on the other hand, serves to conceal the neutral color of the primer. The base coat is usually black or white. I chose black for my model, as this makes the silver paint look better. Now it's time to apply the metallic silver top coating. I use chrome silver. The paint is easy to apply, but unfortunately quite sensitive to the touch even after drying. I had to redo this step because I touched it after putting on the paint. Before I continue, I remove the adhesive strips from the control panel, which will create the black pinstripes. Finally, the clear coat. It serves a dual purpose. It adds a finishing touch while protecting the metallic layer. This is the first time I have used two-component clear coating. It requires you to open a separate internal cartridge first, as shown here. After that, two components are mixed and the bottle can be used for a maximum of 12 hours. The procedure for applying the clear coat is the same as the previous steps. Mix well, then apply in quick, short strokes. The result with the expensive 2K paint convinced me. It really gives a nice shiny finish. I'm really pleased with the result, and I think that all the work was worth it in the end. At last, I can add all the components to my control unit. Like the original, I use a row of colored LEDs to show each monster's attack and defense. There is also a rotary encoder, some pots and switches, and a small OLED display. The control unit is driven by a separate Arduino Nano, which communicates with the main board. For the connection, I am using one of the additional UARTs of the Giga. This saved me from having to use a lot of cables. The control board clicks into place using embedded magnets, and it also has an additional mounting bracket for more stability. Here you can see what the final result looks like. For the cylindrical base, I simply use flexible sheet metal around the unit. The front part opens like a door, making it easy to reach the USB ports and all inner parts for maintenance. And here's what the final table looks like. Thanks for watching.